Okay, hello everybody. Today we're going to do a lab, the Hess's Law lab. We worked on the net ionic equations yesterday and we'll be using them with this lab too. Now I've attached also using Cami this Hess's Law. It's a lab and we'll be going through it. We're going to follow the same instructions and act as if we actually do have these styrofoam cup calorimeters. Now, calorimeters, the coffee cup calorimeters is what it's called. You have two styrofoam cups, and you're going to make some assumptions that you're not losing any heat. And let's make sure you can hear me okay. All right, so we're going to make that assumption that there's no heat loss from the surroundings and that the specific heat in the lab is the same as water. All right, because again, like we said, when we're dealing with aqueous solutions, for all intents and purposes, it's all water, and the actual solute is negligible in this case. So we will assume that it is all water. All right, now I'm gonna be flipping back and forth between the lab itself and the actual demonstration simulation. All right, so I just want to help start you with this. All right, so this is good if you read the learning outcome. All right, that hopefully you know a good amount of this. All right, but you can see down here at number 13 that it says that we're going to determine the enthalpy of reaction, the delta H of reaction of a target chemical reaction using the enthalpy change of two other chemical reactions in Hess's law of heat summation. All right, so again, like I said yesterday, I'm not going to give away Hess's law for you. All right, I want you to discover it. Um, to find it out through this lab exactly what we're doing with Hess's law. All right, so if you take a look at the lab, and all right, okay, so I'm trying to find my lab. All right. All right, so anyways, I'll find it. It's somewhere around here. All right, so what we're going to do is we're going to take a look at three different experiments, reactions that we have, and then we're going to use the lab data in order to discover Hess's law and how we use that. All right, so you can see right here, we have that, I told you our assumptions already. And what we're going to do in the first reaction is it's going to be the solvation, not salvation. All right, that's even better. I get it. All right, but the solvation of solid sodium hydroxide in water. All right, salvation, all right, is the process where your water, because it has the hydrogen bonding IMF, so it's a very strong intermolecular force. So it does break up a lot of substances, such as sodium hydroxide from a solid. So if I had, and we would have it if we were doing this lab at school. We have little pellets of sodium hydroxide. Now, interesting fact about sodium hydroxide, if I put, and I would show the students, I'd put a pellet on the lab table, and the next day they'd come in and it'd be in water. All right, because it's very hygroscopic. What that means is it pulls, the sodium hydroxide pellet would pull the water out of the atmosphere to itself, all right, and become a liquid and then turn itself into a solution, excuse me. All right, so that is one of the properties of sodium hydroxide. So we use it a lot for desiccants where we don't want it to those little desiccant packages, all right. I bet it's not sodium hydroxide, because sodium hydroxide is very alkaline and caustic, but silica is another hygroscopic material that would absorb the moisture, and they put them into certain products that they don't want to have any moisture contamination from. All right, so we're going to look at the first solvation reaction, then we're going to look at reaction 2, which is our sodium hydroxide and hydrochloric acid. We're bringing them together. That's going to produce as a strong acid, which sodium hydroxide is, and a strong, I'm sorry, sodium hydroxide is the strong base, and our strong acid, the hydrochloric acid. All right, when a strong gets together with another strong, when a strong base gets together with a strong acid, or a strong acid with a strong base, you're going to produce water and a salt. All right, remember, salt's a generic term we use in chemistry for ionic substance. Any ionic substance. All right, so in this case, it happens to be our table salt that we're all familiar with and immediately think of when we hear salt. All right, but again, in chemistry, that just is simply another way of saying an ionic substance. All right, so we're going to take a look at the sodium hydroxide and the hydrochloric acid reaction. And then we're going to look at reaction 3, which is the solvation in water of solid sodium hydroxide. So again, I would have had those pellets that you guys would have been taking, weighing out your solid amount, and then putting it in water. And putting it in hydrochloric acid. All right, and that would have been in a solution form. All right, so we have a certain molarity with that hydrochloric acid that we'll be looking at too. And that's going to produce H2O and again the salt. All right, strong base, strong acid. And it's just because it's solid, that's okay. It's still a strong base, the sodium hydroxide solid. All right, so it's going to give us the same products. All right, so let's take a look at our procedure here. All right, so for our first one, we want to weigh about 200 grams of room temperature water into a styrofoam cup. We'll call 20 degrees room temperature in this case. All right, it's close enough. They don't have 25 on this simulation. I probably would have gone 25, although that's a little warm for room temp. So we're fine with 20 degrees Celsius. So we're going to use that as room temperature. And why that's important is because we're going to want to record what the initial temperature is, which will be the 20 degrees Celsius. And then what we'll do is we'll weigh between 3.9 and 4.1 grams of sodium hydroxide onto a piece of weighing paper. All right, let's just call it 4 grams of sodium hydroxide in this simulation. And then we're going to record the temperature of the water in the cup. All right, so the initial temperature. So we want to know what the initial temperature is of the water in the cup. All right, should be 20 degrees. And then we'll add the solid to the water and stir until it completely dissolves. And then we'll measure the temperature after the two have gone through after the sodium hydroxide has gone through the solvation process. So let's take a look at the lab itself. All right, so you've read the learning outcomes. All right, go ahead and click on experiment. All right, now it says please choose one, run the demonstration or run the experiment. We want to run the experiment. So I click that. And you should see something that looks similar or exactly the same as what I have up here. Okay, the one that is on the scale, all right, you could scale, solute, that's going to be the one that goes into our water. Our water will be over here in the calorimeter. And this is a calorimeter, all right? It's a little more upscale than a coffee cup, a styrofoam coffee cup. All right, so what it'll do is this cover will close it. All right. So in this case, we're actually not losing a whole lot of heat to the environment. All right. So what we want to do is start off with our 200 grams. All right. 200 grams of room temperature water. All right. So I'm going to wait on that because that's our second step. All right. So we'll start first with the 4 grams of sodium hydroxide. All right. So I want to go let's make sure it's a solid. Yep. Wait a minute. Wait a minute. I'm on reaction. I want to go to reaction 1. We'll get to this one. Or you will at least. All right. So sodium hydroxide. All right. We're putting in water. Okay. I don't know what I was looking at. I was on the right one. Okay. So have to edit that out. All right. So we'll start with 4 grams of sodium hydroxide. So you're going to choose your solid. So we'll make it sodium hydroxide. You can see I have the temperature at 20 degrees. All right. So I said 4 grams of that. All right. So there's 4 grams. You slide that around. All right. You can show the delta H a solution if you want. It's neither here nor there. All right. And then go ahead after you get your 4 grams, hit next. All right, then what we'll do here is put our water in there into the calorimeter. All right, and we want to have 200 grams of water. Well, again, the density of water is 1 gram per milliliter, so we know that's the same as 200 milliliters. All right, okay, we can do mass here. That's fine. So we do water. We want to get that to 200. All right, and we'll keep it at 20 degrees. And again, if you want to show the specific heat, feel free to do that. That's 4.184. All right, so now what we're going to do is hit next. All right, and on the left there, it'll tell you how to run experiment box. We do want to show the graph view, and it wouldn't hurt to show the microscopic view either. What's actually going on with our ions there? All right, so you can see that it's a graph of temperature versus time. All right, and we're going to take a look at it. It's not real time as they say here, all right, but it'll be about 5 seconds, and that will give us a pretty good idea of what the final temperature would be. Okay, so let me get the lab. Okay, so got the lab. We're back in business here. So what I want to show you is, all right, that we want to go ahead and start the experiment. So I'm going to hit start. You can see that it's going inside of our calorimeter, and we're getting a temperature. We'll wait till it maxes out. You can see microscopically what's going on, how the water's tearing the sodium hydroxide apart into its respective ions. There we go. 25.21 degrees Celsius. All right, so let me write that down somewhere. All right, so let's go to your lab. And we want to use the data table for it. All right, so here is our data table for the solvation of sodium hydroxide in water. All right, so we want to put down our mass of water that we used. All right, so it was 200 grams. All right, the mass of our sodium hydroxide was 4.0 grams. Our initial temperature was 20 degrees Celsius, and our final was, we'll look here, 25.21 degrees Celsius. 25.21 degrees Celsius. Let's put in then 0, 0. All right, to the hundredths for our initial temperature to keep it consistent. All right, so we have our data. All right, excellent. So then what we want to do is hit reset. So down here on the right, you'll hit reset because we're going to go on to experiment dose. That means 2. All right, so let's see what it says here that we need to do. All right. All right, so for reaction 2, we're taking that strong base solution, it's aqueous, and we're also taking the hydrochloric acid, which is a solution also. It says measure 50 milliliters of 1 molar HCl. Add this to the styrofoam cup. So whenever it says styrofoam cup, that means the calorimeter. So that's going to be our second step. So you're going to probably reverse 2 and 1 on this lab, all right, to correspond with the simulation that we're using. All right, so then we want to measure 50 milliliters of 1 molar sodium hydroxide. And we're going to add that to the clean beaker, and we want to measure the temperature. All right, well, it's going to give it to us, so that's pretty straightforward. So I want to get 1 molar of sodium hydroxide, and I want 50 mils of it. All right, so sodium hydroxide, oh boy. Let's see, do I not have it? Liquid solutions, that's why. All right, so you have to go over here to solutions, and then you will click your sodium hydroxide. We want 50 mils of it, so that's right off the bat. That's as low as it goes. All right, and we want it as 1 molar. So you slide it over to 1 molarity. Now you can show specific heat, like you can see it's water. All right, specific heat of water there, because we're talking about the solution. All right, so 20 degrees, all right, we'll say that's our initial temperature. But we're actually interested in the temperature in the calorimeter. All right, so it does say record temperature, so we will do that. All right, and then let's measure out in our calorimeter, because again, it's that styrofoam is our keyword for calorimeter. So we're going to put it into our calorimeter. So I'm going to use 50 mils of 1 molar. Okay, hit next. Go to solutions. I'm going to get my hydrochloric acid. I want 50 mils of that too. And that's also 1 molar. All right, show specific heat. Why not? Okay, let's go. All right, so we look at the temperature there. That's at 20 degrees also. Now we're going to show graph view and show microscopic view, so we can see what's going on in the reaction. So you see where the net ionic equation's happening here too. All right, so you have your ions there that are just floating around. Now, just a little note here. I think you probably can see my mouse arrow. I hope you can. Is underneath the microscopic view, it has the hydronium ion, H3O plus. All right, H plus, H3O plus, same thing. Okay, it's just a hydrogen ion piggybacking on water. All right, so that gives us our hydronium ion H3O plus. Now it's more accurate saying that it's hydronium, the H3O plus, because hydrogen ions just don't float around there. But by convention, we use H plus quite often instead of just the H3O plus. All right, so just wanted to, if you were wondering, hey, where'd my H plus go? It's there. It's there. All right, so let's start this reaction. We got our initial temperatures, 20, 20. We got our molarity, volume, good. So I'll hit start. And I'll wait until it levels off. And we get 26.81 degrees Celsius. All right, so what I want to do now is go ahead and put in my values here. So all right, so mass of 1 molar of HCl. Well, we got 50 mils of it. All right, again, it's a solution, it's water, so we got, we're going to assume that we got 50 grams of it. Mass of 1 molar sodium hydroxide, 50. All right, now the volume that we had of 1 molar sodium hydroxide. All right, so we'll take a look. What was that volume? 50 mils. Duh. All right. I'm done myself. All right, so volume would be 50 mils. Gonna probably want to get that into liters. Having a feeling that they're gonna ask for moles. All right, so we would want to take the molarity times the volume in liters. All right, so that'd be 0.050 liters, but we can do that conversion later. All right, initial temperature, it says the average. All right, we would be doing this 3 times or so, and then we would get an average in the lab. But since we're not in the lab, we're just going to say it's the 20 degrees, 0.00 degrees C. All right, and then we had a final temperature of 26.81 degrees Celsius. 26.81 degrees Celsius. Have to get myself out of the way there. Okay, so that is for reaction 2. All right, and then what you want to do is complete reaction 3. So again, this is the styrofoam cup. I'll get used to it one of these times. this is the styrofoam cup. So that's our step 2. So just swap these 2 steps. All right, and that says 1.9 to 2.1 grams of sodium hydroxide for number 2. Let's just use 2 grams. Okay, so then we'll do 100 grams of 0.50 molar HCl into a styrofoam cup. All right, so I'll set it up for you, but I want you to run it and collect the data. Okay, so we have, in this case, let's reset it. All right, we're on number 3. So we want 100 grams. Well, let's start with number 2. We want 2 grams. That's a solid. So you go to the solid tab in the middle there, and where you want 2 grams of sodium hydroxide. We'll keep it at 20 degrees Celsius. All right, 2 grams. Good. Temp, we'll keep it there. Good. Sure, if you want to. All right, and then we're going to put that into 100 grams of half a molar. All right, so I'll hit next. I'll go to solutions. All right, you can see the temp's 20 degrees. All right, so we want to have hydrochloric. We want to have 100 milliliters or 100 grams. And we max it. Okay. So 100 grams there. Molarity. What do we want? We want 0.5 in this case for our molarity. All right. So then we're ready to hit next. Did that. And I'll go ahead, show graph view. All right. So that's all we can do. We can't do the microscopic view on this one. All right, so we will go ahead and start. Booyah. All right, so we got 31.83. All right, so I might as well just get the data at least, and then you guys can figure out the rest of it. All right, so I have the mass of 0.5. We used 100 grams. A mass of sodium hydroxide is 2 grams. Initial temperature was 20. All right, we'll assume the weights too. We got a couple of, we can read to the hundredths. If we were at school, we could read to the hundredths. All right, so, and you can fix the ones up there at the top, or just remember it, and when you do the calculations, put it in. All right, and then our final temperature here was 31.83 degrees Celsius. So I'll put that 31.83 degrees Celsius. All right, so now we have all our data. So that's muy bien. All right, so then what you're going to do is you'll take a look at the next page here. All right, and you can see that there is reaction 2. So what I want you to do is the calculations on reaction 2 on the left side there, and then reaction 3 on the right side there. So I broke them in so you can do them both in half there. All right, so the change in the heat of water. All right, so in this case we're going to use the Q. All right, that's all I'm going to tell you there. Now, the change in the heat due to solvation and or reaction. All right, our first one was solvation, and so then we had reaction. Now, what I want you to remember is the law of conservation of energy. A little brain slip there for a minute. All right, and that means again, our Q of solvation all right, I'm not going to write you know what it is equal to then our negative Q of H2O. All right? That's all I'm saying. That's all I'm saying. Now, number 3, okay, this is where you're going to have to get the moles of it. All right, so you will do the molarity times volume, and that will get you moles. All right, so after you do that, write down the appropriate moles there. All right, and then for your number 4 here, pay attention to the units. Okay, that's all I'll say there. Pay attention to the units. It's in kilojoules per mole. Kilojoules per mole. Well, number 2, you got kilojoules, and number 3, you got moles. So you figure out what to do with the rest of it. All right, so I'm going to wrap it up there, and let me know if you have any questions on this. And then I want to point something out after you've had an opportunity to do this. I forgot to tell you initially that this is a 2-day lab, so you got today and tomorrow to finish it up. All right, I'll probably come with a quick little video to talk a little bit about this table right here. All right, and then on the back there's a page 4. That is where you're going to use your net ionic equation knowledge and use the net ionic equations for that. Number 6, it wants you just to describe it. So the first one's given to you. Reaction 1, solid sodium hydroxide dissolves. So you tell me what happens in reaction 2 and then reaction 3. All right. Got that? Okay. And then answer number 7. How are the values of enthalpy H1, H2, and H3 related? And I may need to help you on that one, but it should be pretty obvious. Okay. And then 8 asks, how are the net ionic equations for reaction 1, 2, and 3 related? Again, that's more or less saying the same thing as 7, although you'd be putting it into words. All right, conclusion. Give me what we concluded from this lab. What can we do now that we did this lab that you weren't aware of that we could do, but now you are? And then error sources I'm not going to worry about in this case. I'll tell you sodium hydroxide is hygroscopic again, so that means that it could have gained some water during our experiment. That would have been an error source. We couldn't help that. It's just the nature of sodium hydroxide. It's beyond our control. Remember, that's what error sources are errors that occur that are beyond our control. Okay. And then logically, the one that would be another error source is if we were using the coffee cup calorimeter. Well, we assumed we weren't losing any heat, but in reality, yes, we are losing some heat to the environment. All right, and also some heat may be entering into the cup too. All right, so let me know if you have any questions on that, and I will talk to you later.